Thank you. Thank you very much for inviting me to this seminar. I am Kokichi Sugihara of Meiji University, Japan, and my topic is impossible objects. Impossible objects originally meant imaginary 3D structures, which are created in our mind when we see impossible figures. Here are some examples of impossible figures drawn by British scientist Penrose, father and son. The left two are called Penrose triangles, and the right one is called endless loop of stairs. In all of these pictures, when we see them, we have some impression of 3D structures, but at the same time, we feel they are impossible. However, they are not really impossible. There are at least 3 tricks to create real physical objects. The first trick is to use curved surface. We can use curved surface where they look planar and can construct the impossible figures. The object itself is something funny, but if we fix our viewpoint from the special position, the appearance match the impossible figure. The second trick is a discontinuity trick, where we use depth gap, and you can construct the Penrose triangle like that. And I myself was studying in computer vision and tried to reconstruct 3D structures from 2D pictures. And for that purpose, I used equations. And in the equation, we can represent various conditions, such as this face should be planar, and this part should be connected. And we can search for the 3D structures without using curved surface trick or discontinuity trick. And with the Penrose triangle figures, I can find the solutions of my equations. And from that solution, we can construct 3D real physical structures like that. We can see that the faces are planar and the parts are connected, but still we can construct the Penrose triangle. And so what is the trick for this object? I think that we use general angles instead of 90 angles. That is my trick. And so I named this trick the non-rectangularity trick. And so there are at least 3 different tricks to construct 3D objects, actually, from impossible figures. And the non-rectangularity trick looks like, seems the most stable in the sense that when we change our viewpoint slightly, the trick is not visible. And let me show one more examples. The upper part is impossible figure, and the lower is a real 3D object. When we change our viewpoint, we understand that the faces are connected non-rectangular angles, but from this viewpoint, they look rectangular. That's a trick. And the basic principle to construct 3D objects from 2D impossible figures is the following. When we see the pictures, our brains usually perceive some special fixed object uniquely up to scales. But when we search for the solutions from a mathematical point of view, we can find infinitely many different possibilities. This gap between the mathematical nature and the psychological nature is a source of optical illusions, 3D optical illusions, I think. And so, to me, the definition of impossible objects also changes. Impossible objects originally meant imaginary 3D structures, but to me, the impossible objects are real physical objects whose behaviors look impossible. And let me show through another impossible looking behaviors. Here we have an object, and the object looks normal. The 2 windows in both sides of the big pole. And the red rod is moving. That is straight and hard, but it can penetrate the two windows simultaneously like this. At this point, we feel something impossible is happening. But when we change our viewpoint, we understand that the motion is actually possible. But the object itself is not what we perceive when we see the image initially. And an interesting point is that from this viewpoint, we understand the real shape, actual shape of the object. But if we go back to the initial viewpoint, our brains again automatically perceive the rectangular angles, windows. And so we can perceive this impossible motion illusion again and again. So the phenomenon is that object looks normal and motion looks impossible, but actually the object is unusual and motion is natural. And an interesting point is that the illusion occurs again even after we understand the true shape of the object logically. Let me show one more example. Here we have a roof, but the ball goes up to the highest point like that. Actually, this motion of the ball suggests that the part which looks highest is the bottom of the valley. And actually, we understand this when we rotate the object. And actually, the two plates forming the roof are parallelograms, but our brains like rectangles. And so when we see parallelograms, we think they are the slanted appearance of the rectangles. And so we perceive the different orientation from the physical orientation of the plate. And from this point, we understand they are not a roof, but when we go back to the initial viewpoint, again, you may perceive the normal roof structure like that. So until now, I showed that the two kinds of 3D illusions, realization of impossible figures and the impossible motion illusions can be created from the same mathematical principle that the picture has infinitely many possibilities to realize a 3D object. And this mathematical nature can be used in another way. Because there are infinitely many possibilities, we can find one that has the second desired appearances when we see it from the second viewpoint. For example, we want to construct some object which looks rectangular from the first viewpoint and circular from the second viewpoint. To find this kind of object, we can combine two equations and solve it. That's all. And we can construct actually these objects. Let me show examples. Here is a miniature carport, and please look at the shape of the roof. Oh, sorry. The roof looks like circular. However, when we remove the curtain and reflect the object in the mirror, the appearance of the roof changed drastically. And when we rotate it, we understand that we are looking at the same object from two different viewpoints. And when we rotate it by 180 degrees, the two appearances exchanges. And the true shape of the roof is neither circular nor triangular, but when we go back to the initial viewpoint, we again feel these two appearances. One more example is object which looks like circular from the first viewpoint and rectangular from the second viewpoint. And even if we see the objects in motion, it's difficult to understand what is the true shape. And using this method, we can construct similar objects like that. Because they have two different appearances, we call them ambiguous objects. And especially we have a cylindrical object, and so we call them ambiguous cylinders. The construction is the following. Suppose, for example, here, we give 2D shape, heart and diamond, and make equations and construct the solve it. Then we get a space curve, which looks like heart from the first viewpoint and the diamond from the second viewpoint. Then we move this space curve vertically to a certain distance and adopt the swept surface. Then we get a cylinder like that. And when we see these cylinders, because of planes like light angles, the top curve looks like a section obtained by cutting the cylinder by the plane perpendicular to the axis. But actually, the top curve is a space curve, and it undulates up and down. And so it's natural that when we see it from two different viewpoints, they have different shapes. But the similar method, we can construct many like that. And another one is like that. Here we have an object. They do not change their shapes, but they change their way of connection. They are separated from first viewpoint, but intersecting from the second viewpoint. And the background mathematical method is the same. And using this trick, we can construct various objects like that. And another way of this display is to rotate it like that without, instead of using mirror. The light-facing bird faces to the right again when we rotate it by 180 degrees. And even if we rotate it slowly, it's difficult to understand the true shape. These objects has opposite direction when we use mirrors. And I have to show that these objects are very stable in the motion of the movement of the viewpoint. Here, we rotate the object to the right and to the left about 50 degrees, but still the illusion does not disappear. So it's very stable. And we can also construct similar object in the large scale. This is a snow slide with anti-gravity motion illusion. And this is a walkable endless loop of stairs. In the non-rectangularity trick, we can use the object in the way connected, and so we can walk on this. Now, this is a summary of my method. I have shown 3 different types of impossible objects, but they all can be constructed by the same mathematical principle. And the first one is a 3D realization of impossible figures. In that case, we are given the impossible figures and we fix a viewpoint and construct the equations and solve it. If it has solutions, we can construct the impossible, we can construct 3D objects whose appearances match impossible figures. And because we can state the planarity and the connectivity in the equations, the realized object has no curved surface and no discontinuity gap. And the second one is impossible motion illusion. In that case, we first choose a normal object and project it and get the picture, and then solve my equations and get another object. And when we show this, the audience perceive this, and so we can add the impossible looking motions. The third one is ambiguous cylinders. In that case, we first choose two desired shapes and construct the equation and combine them to solve solve it. And in this case, the solution, if it exists, is unique because of the triangularity principle, but we can construct the impossible object like that. Thank you very much.
Thank you. I have a few questions for you. Well, first of all, I think you should start an amusement park, a sort of Disneyland of this kind of illusions. Seriously, have you thought from a cognitive point of view why the human visual system is vulnerable to these kind of illusions? Have you ever wondered why we can fall so easily for these illusions?
My impression is that the human brains like 90-degree angles very much. Actually, the pictures we get in our retina are 2D structures, and it does not convey 3D information, depth information. And when we perceive 3D objects from 2D pictures, it's actually we are just guessing. And in that point, there are mathematically many possibilities, but the human being usually guess only something most rectangular. That gap makes this kind of illusions possible, I think. And it's difficult for me to answer why the human beings like 90-degree angles.
Can you tell us briefly something about you, how you got intrigued by this? How did you get into this unusual field?
Oh, when I was young, I was doing research on computer vision, where the goal is to design the artificial eyes for robots. And I found the 3D object reconstruction equations. And in order to check the correctness of my theory, I showed the impossible figures to my system, expecting that the system answers it's impossible. But it answered it's not impossible. And actually, we can construct 3D structures. And so I have an interesting that why human being feels they are impossible, although they are mathematically possible. And so I extended my research interest also to human perception. That is the yes.
Good. You have a question. Can you see the QA on your Zoom?
Oh, okay.
Can you see them?
Okay, let me read. This is actually brilliant. Thank you very much. I wonder whether these illusions also work for people that come from a background that is not based primarily on rectangular geometric and round cylinders. Yeah, I want to know. And I sometimes discuss with my colleagues who are interested in this field. And but they say that it's difficult to find people nowadays in the earth who are not grown without rectangular world. And so actually it's difficult to check, but I imagined even if we are not surrounded by rectangular world, the human vision systems may have some priority to special features. They are not necessarily rectangular, but something. This I feel this because if the human beings can understand all the possibilities which a mathematical equation tells us, then it's difficult to recognize the object and to recognize the scene in short time. The human vision system has most important work is to recognize the situation and to use it for their action. But if we consider all the possibilities, then it's difficult to judge or understand the scene in front of us in short time. So that is not good for taking actions. For example, if something is coming to me, and the most important thing is to avoid by moving. But if we consider what is that, this is one of the possibility and this is another possibility and so on, we cannot survive. That is my feeling.
Excellent. Thank you very much. Thank you, Kokichi.
Thank you.
Very nice presentation. And anybody who's interested, you can go to his website or just go to YouTube. You'll find more of these fascinating ideas.
questions?